The sequence generator procedure is so useful that I figured I'd make a short video on it. Here's some examples of what you can do with it. You can generate a range of values. You can repeat an expression. And of course, you can create a sequence, which is especially useful for filling in contents of a list of vector matrices. Let's get started. Okay, let's start with using the sequence procedure as a range generator. For example, what if I want to create the sequence from -5 to 2, incrementing by the default value of 1? Sequence from -5 ... 2, incrementing by 1, and that's your sequence. Or we could do a sequence from -5 to 2, but now increasing by 2 every time, and you get this sequence. We can also do a reverse direction. We can actually start from 2, go down to -5, and decrease by 2 every time, and that's this sequence. We can even create a sequence of fractions from 0 to 3, incrementing by 1/2, and you get this sequence. Of course, we can even do it as a floating point, 0 to 3.0, incrementing by 1/2 each time, and now these are the floating point numbers. You can finally also sequence letters, and we'll skip every second and third one, and those are those letters there. Okay. Probably another useful thing is to make an expression repeater. For example, what if I want to make 4 zeros? So I have a sequence of 0 4 times, and that will make zeros 4 times. It's particularly useful for building up lists. For example, my list A is defined as a list, so it's open square bracket, a sequence of, we'll put a bunch of 99s in there, and it puts 99s into the list. Of course, what we can also do is we can extract information out. For example, if I say, what is the sequence of A? That means, tell me what is the sequence within the list of A. Finally, the most important thing is to use the sequence to generate a bunch of numbers that may be unique. For example, let's say we want to create a sequence of n squared values from 0 to 5. So I want to make a sequence where I want to calculate the integer squared, and the integer will start from 0 and go to 5. And that's what it will produce. And again, this is great for generating lists. For example, my X list is open square bracket, because we want to list a sequence of, let's say n cubed from n equals 0 to 5. Now let's make it to 10, and we'll skip every third one. And those are the values that will be placed in there. Finally, you want to fill in, say, a vector with a specific number of elements. Well, that's where the num elements option comes in useful. For example, let's make a vector using the fact that it looks like a vector, so it starts with the greater sign. It's a sequence. The values will be x, and x will go from -1.2 to 6.7, and I want to put in the number of elements equals 6. This way, it will go through, look for all the 6 that start from -1.2 to 6.7, and fill those in, and there's our finished vector. Okay, for my final example, let's look at where you may need to plot something by the values and not necessarily by the function itself. So I'm going to create a floating point pi, which is the evaluation as a floating point of pi. In fact, there we go. I can hit the escape button, constant pi. So that is the actual value of pi. I will make 22 points. And what I'm going to do is I'm going to create a bunch of points within a list. So the points are at x and the sign of x. What is x? X travels from minus this floating point pi to the other floating point pi, and I want 22 points of that. When I'm done with it, then I'm going to plot these as a style of point using a particular symbol size. So again, notice this is the symbol pi that we have made out of the mathematical constant pi. And again, we're going to create a bunch of sign points for which we plot, and now we have a plot of all those points that are evenly spaced from minus pi to plus pi. The sequence generator procedure occurs so often you'll probably memorize it anyway. You can read more about it from the document at gould.prof/learningmaple. There's also an operator known as the $sign. I don't tend to use it. I don't recommend it, but you may see it.